In this video, I want to follow up a little bit about my volume discussion. Hopefully you saw my previous video where I showed the volume of a rectangular prism using blocks. I had a 2x3x4, and I think a lot of you probably learned that volume is length times width times height, but you have to be careful. That only applies to rectangular prisms, okay? And so I'd like you to think about volume a little bit differently. In this section, we're going to be working with prisms and cylinders. And prisms and cylinders both work the same way. They both have congruent shapes on the top and the bottom, and they have straight sides connecting them. And what happens is, if you remember in my example with the blocks, I had a 2x3x4. There are 6 blocks that would fit across the base of that, okay? And then I had another set of 6 blocks that would go on top of that, and another set of 6 blocks, and another set of 6 blocks. Because it was a prism, I was stacking the same shape on top of itself over and over and over again. So if I could figure out how many blocks fit in the base, in other words, the 2x3 base that had an area of 6, I just knew that I had 4 sets of 6. And so the visual here really is that volume is equal to the area of the base. And I'm going to use a capital B to represent the area of the base. So you're going to have to find the area of the base and then multiply it by the height, okay? And that's going to work for any kind of prism, any kind of cylinder, all right? So just to give you a couple of ideas here. So for example, let's say this prism right here, let's say that the base was a 2x4, and let's say that the height was 5, all right? If you're going to find the volume of this, you could say, well, what's the base area? It's a 2x4. That means 8 blocks would fit across the bottom. And then it means we would stack 8 blocks 5 times to get up to the top. We would take 5 8-block rectangles and stack them on top of each other, okay? So the area of the base is 8, and the height is 5. 8 times 5 is 40. 40 cubes would fit inside this. So we would say that this is 40 cubic units is how you would write that, okay? Now, this formula still works for other kinds of prisms, but you need to make sure that you actually have the bases of the prism. You've got to have the same shape being stacked on top of itself over and over again. So here's an example of a triangular prism, all right? A triangular prism, if you notice, we've got a triangle base. It's a little 3, 4, 5 right triangle, okay? The height is also 4, okay? So blocks are not going to fit into this evenly. You'd have to slice blocks and that kind of thing. But the same idea applies. If you find the area of the base, okay, the area of that base, we've got a base of 4 for that triangle and a height of 3. The area of that triangle should be 6 square units, okay? What that means is I could fit 6 blocks into that triangular base. And again, I'd have to slice them and kind of rearrange them. But 6 full 1-inch blocks could fit into that base, okay? Because the height's 4, I've got 6 blocks for this slice, I've got 6 blocks for that slice, 6 blocks for that slice, 6 blocks for that slice. It's the exact same thing stacked on top of itself 4 times. So once again, the formula still works, okay? The area of the base is a triangle. It's a 3x4 triangle, base of 4, height of 3. So half of 4 times 3 is 6. That's my base area. And then my height was 4, and we could say that there would be a total of 24 cubic units that would fit inside that prism, okay? 24 cubes, 24 1x1x1 cubes would fit in there. And again, they'd have to be cut weirdly to fit into the diagonal parts of the triangle, but that's how many total would fit, all right? The neat thing here is the same thing will also apply to a cylinder. A cylinder is basically a circular prism, okay? You've got a circle bottom, you've got a circle top. And you can imagine, for example, a stack of coins. If you stacked a bunch of quarters together, you could make a cylinder. Each of those quarters would be a little kind of disc shape like this. So same kind of thing. I can find the area of the base. The area of the base there is pi times the radius squared. That would be 4 pi, okay? It's going to be a little bit more than 12. And that tells me you've got a little bit more than 12 blocks that could fit in one level of the base. So if I slice this into 1-inch high pieces, there would be 3 of those discs stacked on top of each other. And this one would have 4 pi and about 12 blocks in it. This one would have 4 pi, about 12 blocks in it. That one would have 4 pi, about 12 blocks in it. We'd add all those together, we'd have a total volume of 12 pi, which would be a little bit more than 36 total blocks that would fit into it, okay? So because it's the same shape stacked on top of each other, from the base all the way up to the top, this same formula is still going to apply, okay? The area of the base is pi r squared, that would be 4 pi. The height was 3, and so we get a total of 12 pi cubic units, which again would be just a little bit more than 36, okay? Now, if you look at a textbook, they're gonna give you 2 different formulas. They're gonna say for a prism, the volume is equal to the area of the base times the height. They're technically gonna give you a different formula for the cylinder, okay? That formula works for a cylinder, and that's how I think about it. However, how do you find the base of a cylinder? You find the base area by taking pi r squared. So for a cylinder, typically in most textbooks, they're gonna say the volume is equal to the area of the base, which is really pi r squared, okay? That's the area of the base, and then you're still multiplying by the height, okay? This formula will work though, okay, if you want to think about it as the area of the base. But again, it needs to be the area of the base, not a length of the base, not a width of the base, the area of the base. So you could do pi r squared times h or base times height. And notice, if I did pi r squared h here, that would be pi times 2 squared times the height of 3. That would still be the same 12 pi